In this video, we are going to find out one way of taking one sequence and making another sequence out of it. And the way we're going to do that is to find the partial sums of a sequence. So first we're going to define what that is, then we're going to show an example. Alright, so suppose we have a sequence, any sequence, starting with A0, A1, A2, A3, A4, etc. We're going to make a new sequence we'll call S0, S1, S2, S3, etc. as follows. So the first one, S0 is not going to be very exciting. It's just going to be the same as the initial term in the original sequence, A0. But S1, we're going to take A0 and add A1 to it. And then S2, we're kind of going to do the same thing. Starting at A0, we're going to add all the terms that go up to A2. So A0 plus A1 plus A2. For S3, we got A0 plus A1 plus A2 plus A3. And hopefully you see the pattern by now. In general, our term Sn of our sequence is going to be the sum A0, A plus A1, all the way up to An. And that sequence, the way we define it that way, that is called the sequence of partial sums. So every sequence has a sequence of partial sums that goes with it. So here's an example. Here's a particular sequence. The nth term of the sequence is going to be n squared. So that's just our sequence of squares, perfect squares. So here are the first few terms, 0, 1, 4, 9, 16, 25. So let's find a few terms for Sn. So the first one is just going to be exactly the same as the first term for the original sequence. So S0 equals 0. For the first term, we're going to take the first term of the original sequence, 0, add 1 to it. That's the second term of the sequence to get 1. S2 is going to be 0 plus 1 plus 4 equals 5. S3 is going to be 0 plus 1 plus 4 plus 9 equals 14. And it's going to keep on going like that. So S4 would be 0 plus 1 plus 4 plus 9 plus 16. And you keep on going like that. So what you're going to be doing in the in-class activities, and what we're eventually going to have a nice formula for, are certain nice formulas, nice closed formulas, I should say, for certain sequences of partial sum. In particular, we are going to look at arithmetic sequences, and those partial sums are called the arithmetic sums. And we're going to find a closed formula for geometric sequences, and the partial sums for those are going to be geometric sums. And we're going to find closed formulas for both types of partial sums. All right, so now you can. Why don't you try doing the problems in the introduction to arithmetic and geometric sums, and then when you've got that, sort of introduces you to the type of techniques that you're going to use, and then go to more arithmetic and geometric sums after that to get to some of the more advanced problems.